So Narcissus clouds are high altitude at the top of the troposphere, and they're actually easiest to see in locations that are near water, so island nations, and they are more common, or they occur more likely in what I would consider my colder latitudes. So I have to go farther in my latitudinal points. So anything like 40 degrees north latitude up to 90 degrees north latitude, and same thing, 40 degrees south latitude to 90 degrees south latitude. So I'm talking about poles to about where we're located. And they create these kind of wispy things. They're also tend to get pulled by our jet streams if they're occurring near jet streams, so like our northernmost jet stream or a polar front location. We can see them get pulled apart. So one of the locations that sees a lot of Narcissus clouds has to do with Ireland, and a lot of Banshee lore comes out of Narcissus clouds. So it's one of those cloud forms that has a very interesting kind of lineage or folklore that moves with it. Narcissus clouds can precursor storms getting pulled in or blown in from out to sea. And so you think of like a banshee screaming, but high wind currents, so creating whistling noises. And so there's a lot of folklore once again with them. You get this beautiful coloration when the sun is setting, and that has to do with the refractivity of light at that angle. So as I change my angle of refraction coming off the solid water particles. The final one, noctilucent clouds, is the exception cloud. This is a cloud that is not occurring in the troposphere. This cloud is actually occurring in the mesosphere. So as we go up, once again, troposphere is near the surface of the Earth. Then I have stratosphere. Then I have mesosphere. And then I have thermosphere. So once again, everything down here in the troposphere is cooling off as I increase in altitude. Everything in the stratosphere is warming up as I increase in altitude. Everything in the mesosphere is cooling off as I increase in altitude. And then finally, everything in the thermosphere is warming up until I run out of actual little air particles. And then I've left my thermosphere. And I've moved into what's called the exosphere. So noctilucent clouds are occurring in what I consider the mesosphere. Well, not I, everybody considers the mesosphere. And they are luminous and what we call night clouds. They're something that we can see very late in the day or at night. Otherwise than that, we won't even notice them when sunlight is blaring in through the atmosphere. And these are luminous clouds. They're thin. They're moving pretty rapidly on the upper parts of our atmosphere. And so they'll look wispy as they flow through. And if you want to watch a little bit of these things moving, you can click or look up the YouTube link and actually watch them wisp. And that image is taken from near the North Pole in their region. But these are incredibly high altitude clouds. And there's something that we in science didn't really notice existed until after we began traveling into space. So we're not even sure if they are naturally occurring or if humans have made them occur by traveling through the mesosphere and putting exhaust in the mesosphere. So creating a situation of humidity being able to find condensation nuclei to stick to. And they're also a potential precursor for climate change. And so we're watching them a lot as an example of what could happen and what we can figure out and whether they're actually human-induced or human-caused. And so there's a lot of mystery and information and a lot to learn having to happen or revolve around noctilucent clouds. So now on that note, I'm going to flick back to your PowerPoints to finish up with how we will categorize clouds and sky cover and things like that. So now that we've gone through the 4 categories of cloud, high altitude, middle altitude, low altitude, and vertical. High altitude has the word seer in their root name. Middle is alto. Things on the low altitude is stratus. And then my cumulus clouds, cumulus congestus, and cumulus nimbus clouds are my verticals. So these are my different categories of cloud. And then we went through some of these weird ones that are there. And those are not the only weird ones. There's a couple more that can fall into the category of strange or interesting cloud forms. One of the keys is to receive a name and be considered a cloud form, you have to have an exact recipe as to where you're located or how you're forming that makes you unique and different that we've figured out. Otherwise, we can probably stick you into one of these four categories. And even as I'm talking about that, some of those cloud forms that we've talked about, I can kind of stick them into these categories. Like I said, the Narcissus clouds, for example, are kind of just cirrus clouds that happen to be occurring late at night and moving rapidly in a jet stream. So there's a little difference, but they are within one comprising of that type. So sky coverage, if my sky happens to be a 9th to 10th of the sky covered, so it's almost completely covered or completely covered, I will consider that overcast. If coverage is between 6/10 to 9/10, then I will consider it broken skies. If I use the word scattered, it's anywhere from 1% coverage to 6% or 6/10 of a percentage covered. And then if I see less than 1/10 of my sky covered, I consider it clear. Now, why these percentages? And that's because I will observe it based on this little observation box. This is a cellumeter, and cellumeters determine how much sky coverage I'm receiving or how much sunlight is breaking through my sky coverage, and it's 1/10 of my sky view is what I'm looking at. So it's reading the amount of collected sunlight based on sky view, and it's how much of that coverage box am I getting covered, whether it be completely covered, broken coverage, scattered coverage, or clear. So when you hear these terms, there's specifically an amount of cloud cover that I'm seeing in my process. Another way that I will observe cloud coverage is through satellite. And I can see these through 3 different forms of satellite enhanced imaging. A is visible, B is an infrared on my imaging, and the final one is color enhanced infrared satellite imaging. Once again, if I'm talking about infrared, I'm actually talking about sending out a specific electromagnetic spectrum wavelength, specifically infrared wavelength, which covers anything from my near infrareds, middle infrareds, all the way up to my thermal infrareds. And this is going back to, I believe, Module 2, where we talked about spectrum of light. And I'm actually sending out those wavelengths, and I'm picking up the material. Where with visible, I'm talking about exactly what's in the visible spectrum of light as I pick up my satellite image. And so on that note, this covers our chapter set about cloud cover, cloud formation. And there's a lot of categorization. There's the 4 ways I can make a cloud, the 4 categories I could stick a cloud into, and then how do I observe and categorize or talk about cloud cover itself. And so a lot of this has to do with observation skills and ways to explain what I'm looking at. We've also covered within this chapter stabilities. So we're talking about stable versus unstable atmosphere, conditionally unstable atmosphere, and then extreme stability within my atmosphere.